For this experiment, you will need a level air table that, when the air pump is running, is virtually frictionless. A piece of track paper is placed on top of the carbon paper, and this is where all of our dots from the spark timer will be placed. Now, to begin this experiment, we set the spark timer to 100 milliseconds, and what this means is that a dot will be placed on the track paper by the air puck every 1/10 of a second. Now, to do this experiment, we place the air puck on top of the track paper, give it a slight push, and then activate the spark timer. So once the air puck has placed those dots on the track paper, we take the track paper and place a meter stick on top of it and measure the distance from the very first dot to each successive dot. Keep in mind these dots are 1/10 of a second apart. So here you can see on the left, the meter stick 0 is placed on the very first dot, and you can see the very next dot, which is 1/10 of a second later, is at 2.8 centimeters. And I'll pan across this pattern, and you can measure the distance for each successive dot, which is that of the object, every 1/10 of a second. Depicted here on the right side of the screen is a dot at 1.2 seconds, and you can see it's around 34.9 centimeters from the beginning. Now, with this information and the worksheet that accompanies this video, determine the relationship between the distance and time for an object traveling at a constant speed.